So we talked about collection. It's a framework that provides like efficient manipulation of a group of object. And we talked about the hierarchy of collections, where java.util.package has, which is the predefined Java predefined library that contains all the classes and interfaces for the collection framework. And we talked about array, array list and linked list. So array has like a definitive, it knows its size. So if we want to add something to it, so we have to change the size of the array. In the array list, it accommodates any number of size at runtime. It is better for storing and accessing data, and it also takes duplicate elements. And linked list, it's like it's a dynamic data structure whose size increases as we add the element in the element in the list. So the linked list is better for manipulating data. Yeah, that's all I have.
You say manipulations, yeah. I mean,
yeah.
Thanks for that, Varsha. So, like, see, basically, when we talk about linked list, the key difference between linked list and array list is linked list maintains insertion order. And if you look at the back-end data structure they use, array list uses an array, dynamic array. So we know, right, in an array, the data is stored in a contiguous memory location. So whenever you remove something, there is a lot of memory compaction that goes in the backend, right? But whereas in linked list, it doesn't store it. The value element linked list is based on linked list data structure itself. So the data doesn't store in a contiguous memory locations. So there is no compaction and compaction, that memory compaction operations. So when you have too many, if you want to just store data and access it, array list is better. On top of that, if you have too many insertions and deletions, then we'll go for linked list, because it won't compact every time you remove or insert or delete something, right? It will expand. I mean, it's not stored in a contiguous memory location. So there are no additional things that are involved when you remove and add elements. So linked list performs better there, right? Like I was saying in our last class, the key idea depends on what is the functionality you have, and you should pick the best one to suit your purposes. Okay, so the same collection hierarchy, whatever we discussed, it's here. This is the same one what I have showed in the what we have drawn the diagram also here, right? Only thing is the map which we draw here, it was not part of this particular diagram. Okay, whatever you're seeing, the same hierarchy. Okay, we need to focus on the blues. Okay, blues are your actual array list. Actual collections which you will use in your day-to-day program. Vector is a legacy one, so you can ignore it. But array list, linked list, stack, 𝑅𝑑q, priority DQ, right? And again, hash set, linked hash set, tree set. Your linked list has a queue kind of mechanisms as well. Okay, it behaves as a list and a queue because it implements both interfaces, right? And on top of collection interfaces, I think yesterday we also have an 𝑖 interface, right? So basically this 𝑖 interface is implemented by all these classes, the blue ones. Okay, so this 𝑖 has one method and it's implemented by all these classes, concrete classes of the collections, right? And this 𝑖, it basically returns an iterator. Like if you see here, that's what this iterator is used to iterate through the elements of the collection, right? So we created an iterator from this array list yesterday, amplist.iterator. It returns as an iterator, and using this iterator has next, and the next using has next will check if there are elements still present, and it will loop through, and next will print the element. So it printed all the objects one after the other, which we saw yesterday, right? I'm just executing this program again. So likewise, using iterator, we can iterate through elements of the uh, array list or linked list or everything. Okay. And you guys also understood that for objects, we are overriding toString method to return the string representation of that object. Else it will return the memory address, isn't it? If you don't override a toString method. These are few things we discussed yesterday, and okay. So having said that, let's talk about today. We'll just discuss few more topics, right? So I'll just go back to the slide here. So if you see, right, like we have a different collections here, right? We have an array list, we have a linked list, we have hash set, linked hash set, priority queue, hash map, linked hash map, tree map, tree set, different collections, right? So for all these collections, they differ in terms of in the backend what kind of data structure they are typically implemented. When I say data structure, it is a logical concept on how it is implemented and stored in the memory. Okay, and this table tells you the data structure that is being used. If we talk about set, in set we have hash set, tree set, linked hash set. Hash set uses hash table. Okay, and whereas linked hash set uses hash table and a linked set. Tree set uses balanced tree. These are the backend data structures. I mean, if anyone from computers background, you know what is a data structure, right? So we'll not get into much of these concepts, but I'll just give you a quick overview of it. Okay, so how exactly they differ. I think let's talk with array, right? Resizable array means it can vary at any point. If you take array, right? If you suppose we have 10 elements like this, okay? 1, 5, 4, 3, 2, something like this, right? 5 elements. If you insert them in array, it will, this is a Java memory, let's assume, right? And here, your array will be storing these values in a contiguous memory locations like this. It will create these 5 places, and this is how it will store in case of an array. Okay. 3 and 2. This is your array data structure. Are you guys following me? Hello?
Yes.
So this is the array data structure. So this is the resizable. When I say resizable array, that means my array can grow at runtime. Okay. So if you want to 2 more add elements, it will just add 2 more elements next to this. But remember, this will be added in a contiguous memory locations. Okay. Normally, if you think of your memory, it will contain so many rows and columns like this as a table kind of thing. It will contain like this. Okay, and you have to store 5 elements. So your array will find some place where it has 5 continuous blocks. Wherever it will get memory, it will go and store there. If you add 2 more, right, then it will try to take more boxes. Okay, and if you delete 4, for example, if you're deleting this, right, then your memory will be compacted. That means the 3 will shift into previous block and 2 will shift into this block. So there is a memory compaction that is happening here. Okay. So insertions and deletions, costly operations in case of array list, because they take more time because of this the nature of the data structure, the way it is stored in memory, right? So, but to store elements and to access it, it is definitely the best. You have index-based access and all, right? And coming to linked list, if at all you store these elements in the linked list, and before that, so the array-based data structures we have are array list and DQ. Okay, so DQ is called as a double-ended queue. When we say double-ended queue, I'll just come there. Just remember it for now. Okay, so array is based upon array list and a DQ. Okay, and then you have a linked list data structure. Okay, so how linked list works is it works something like this. Okay, if at all in linked list, if it has to store these elements, it will randomly store in the memory. It will randomly store like 5 elements like this. Okay, and these are called nodes. Every node will have two parts. One is the data element and one is the address element, like this. Okay, so the value 1 will be stored here. Okay, and value 5 will be stored here, and the address part will point to the address of where 5 this element is storing. So basically that means every element will store the address of the next element in the list. Okay, you got it right. And 5 will point to this, and this will point to this, this will point, and this will point to this. So this is how it works. Okay, here you will have 4. So here you will have 3. Basically, they get stored at a random memory locations in case of linked list. Okay. If you notice here, the data is not getting stored at a contiguous memory location unlike array. It is storing at a random memory locations, right? And one node will have memory address of the next node. So that way it can find the chain like this. It can link all elements as part of that particular linked list using this address part, right? Suppose you are deleting 4, for example, in the same scenario. Let's take the same. You're deleting 4, right? This address will simply point to 3. That's it. It's a very simple operation. So that's why the insertions and deletions are very easy in linked list, right? So this is the key factor when you try to choose between a particular, suppose in this example, when we want to choose between array list and linked list, this is the key factor. Both will store duplicate elements. Both array list and linked list will store duplicate elements. Both, but the key idea is both are good for storing and access. But when you have a situation where you're doing too many insertions and too many manipulations in the data rather than just storing and accessing, then you should go for linked list rather than array list. Your program execution will improve. Okay, if you're dealing with thousands of objects which you're storing in your linked list or array list, then that will definitely make a difference if you're doing too many insertions and deletions, right? So accordingly, you have to choose. As a programmer, you need to decide on which collection you need to use, right? And now coming to the next data structure, hash table, right? Hash table stores in a table kind of a format like this. Okay, it will have a key value pair mechanism. Okay, so it will store data in this format. You have a table. Okay. So here you're storing 1. 5. 4. So this is how data gets stored in a hash map, and this is called a key. First column is called a key and a hash table. Okay, second is called a value, and key can be anything. Okay, it will compute key based on something called hash code. Okay, this is hash table. It uses hash code. So for every value, it will compute something called hash code. Okay, and the key will be the hash code. The key will be called a kind of hash code. Okay, and it will store data in this format. Okay, this is a hash table data structure. Okay, but this is the way we look at it logically, but internally if you take, it will store in the form of both array list and linked list. Okay, so I mean, this is one of very famous interview question. They'll ask how your hash map or hash table works. I'll just explain that a little later. Okay, but for now, just remember this: your hash table will compute hash code for every value. Hash code can be, think of hash code as a key. It is considered as a key. So when you compute hash code for value and key, whatever you get, that will be considered as a key, and that will be unique for every value. Okay, as a programmer, we should be responsible for implementing efficient hash code algorithm for our objects, so that for every value our hash code will be unique, right? So we need to implement it in such a way, and in memory it would be represented in this kind of a key value format like this. This is the hash table data structure. And then you have tree, balanced tree. In case of balanced tree, elements will be stored in this way. Okay. Have like this. I'll just put the tree first. One. Like this. Okay. So this is a balanced tree data structure, and the tree set and tree map they use. But what is the key difference between these and this is, in case of a tree, elements are stored in sorted order. Okay. So when you look at a tree data structures normally, okay, especially the tree map and tree set, whatever we have here, you will see the elements getting stored in a sorted order. I think the typical way here, actually they would get stored is in a sorted order like this. Okay, one is the smallest. It will take ascending order by default. Okay, it will store 2 here. It will store 3 here, right? And it will store 4 here, and it will store 5 here. Okay, so these are the trees. Okay, it's like a tree structure. You have one parent and 2 childs. These are called root nodes. These are child nodes. And for 2 siblings is 3. For 4 siblings is 5. So there are a lot of, this is a tree data structure. Okay, so based on this kind of approach, you have a tree set and a tree map. So likewise, right? And if you look at linked hash set and linked hash map, they are combination of 2 data structure implementations like hash table and linked list. Okay, so this is what it is. Any question up until this point? I'm just giving you how they are, what is the key difference in terms of a basic fundamental perspective, the collections. Is it clear? Now, a couple of key things to remember here is, right? here, if you take tree map data structure, right? Tree tree data structure here, you're getting elements in a sorted order, which is not a feature that you get in array list or linked list or hash table, right? So that's one good thing. And again, in tree hash table, if you see, since you are computing hash code and your key should be a unique value, that means you cannot store duplicates in a hash table. Because if you store duplicates for two values, hash code will become automatically same, right? When you generate, if you're trying to store two times, then for 5 value hash code will be same, right? So it will not allow. So you can't store duplicates in hash table. So like this, in each one of these data structure has its own unique attributes, which basically kind of uh, varies them or makes it significant compared to the other data structure. So as a programmer, our responsibility is to understand this and choose appropriate data collection when we are tend to do some task, right? When we have a lot of data and group of objects which we want to work with, depending upon our scenario, we will be definitely we need to pick one of these, right? So okay, any queries up until this point? No, right? Okay. So okay, now I think yesterday we saw this employee object and we created 4 objects, right? And if you see here in array list, I'm just trying to store the 5 objects. I'm trying to add even 2 times, and using iterator, I iterated through all this and I kind of printed them, right? So I'm just executing this program here again. If you see, we are printing those 5 objects, right? So instead of using iterator is very old style. Okay, you can also use the for each loop style. This is the latest one. Okay, so you can use, this is the for each loop style. If you see, I'm taking an employee object. Because in emplist you have employee objects, right? Emplist is storing nothing but it is storing employee objects. So I'm just iterating through each employee object and I'm doing sysout println e. Okay, I'm just commenting this part. This will also print the iterate to the list, and this will also print the all objects. So you can, to iterate through a collection, you can use an iterator or you can use a for each loop style, the one that is here. Okay, and if I control Z, yeah, if I have to remove certain element from empty list, right? So I have this method. Okay, I have a lot of methods in array list, which basically comes with predefined methods like this. Okay, 1 second. Okay. You have okay, I'll left this now. Now, if you see, we can print emplist.size. Size is 5 because it contains 5 elements, right? E1, E2, E3, 4, and E1. Okay, and now next thing is set. Okay, so in interview normally they'll ask you one a regular question. It's a quite popular question. Okay, and I think many experienced programmers also, they tend to confuse and they'll not be able to answer it efficiently. Okay, so they'll say that you have an array list, and array list will contain duplicates. Yes or no? Right? It will contain duplicates, isn't it?
Yes.
That's what we discussed, right? And they'll ask you a question like this: can you let me know how can I remove a duplicates from array list? Okay, this is the question. They'll ask you to remove duplicates from array list. So what do you think you can do? What are your ideas? Just come up with some answers. I gave you an array list, okay? And there are 1,000 objects in it, and almost 100 objects are duplicated. Like unique, only unique or distinct are only 900 objects. Now, how can I actually remove them from my array list? You guys understood the question, right? Guys, have you guys got it?
Yes,
Okay. So then what
we
is
can use the
yeah, whatever just comes to your mind, just say it. The moment you are thinking about answer, that's when you're taking the next step to basically grasp this or comprehend the concept, right? So try to think about some solution. I'll give you guys 15 seconds. I have an array list and I stored 1,000 objects in it. 100 are duplicate, only 900 are unique. How can I remove those 1,000 objects? Sorry, 100 duplicate objects.
As we can use the link has said as a collection.
Okay. I think you're close to the solution, Asha. Go on. You'll use linked hash set, is it?
Yeah, and yeah, I'm sorry, Sam.
Okay. Okay. Yeah, I think you're somewhere close to the solution, Asha. Okay. See, the idea is normally what people tend to do in the interviews, they get nervous and they'll think too much. Okay, what they will tell, like, I'll create a for loop, I'll try to iterate through each element, I'll develop a logic to find the duplicates and all, blah 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 blah, you know, something they will say. Okay, but if you understand, to store to not to have any duplicates and to have a similar array list kind of a data structure, we have set. Okay, so we can choose hash set. We don't need hash map because here we don't have any key value pair mechanisms, right? We just have only one value. So we can go for hash set here. So what we will do is we can iterate through array list and we insert each elements in, we will try to insert all 1,000 elements in array list into hash set. What will happen? Hash set will only take 900. It will not take duplicates because hash set internally uses hash code, right? It will try to compute hash code for all the 1,000 objects, and it will feel that for 100 objects which are duplicates, the hash code will be same as the remaining as part of the 900 unique objects. So it will simply overwrite and it will ignore them. So by converting a array list to hash set, you can remove the duplicates in an array list, right? So that's how, and again, you can convert that hash set back to array list. Okay, so you iterate through for loop and you insert it. Or else the best approach is when you create a set like this, right? I see, if you see here, I'm creating a set emp set new hash set. This is my emp list. Here I'm creating emp set. And when I'm creating it, look at the constructor. In new hash set, I'm passing the list. So this will automatically give me unique elements in my set. You guys are getting it, right? So I'll just show you here. So suppose I'm iterating through mset here. Okay. Why there is this error? Just put this to remove that error. Okay. So here we are iterating and placed. So I'll say link list. Okay. And here we are saying print set. So now let me just execute this program. And here I'm printing the size of set. Okay. If you see the output, see here. Here in the list, Varsha, Asha, Shweta, Sheila, and Varsha. You have 5, and when we print the size, it is printing size, which is you have 5 elements. And here, what I did was I converted my list to set, because when I'm creating set, in the default constructor, it takes the list as an argument. So I'm using that particular constructor which is already available, and I'm passing the emp list here. So that way I'm converting my list to a set. So when I do that, if you see, it is storing only Varsha, Shweta, Sheila, and Asha. The duplicate value, which is Varsha, it is not storing it, and size is also 4. Right? Did you guys notice the difference now? Okay. If you want, you can add more names here. Okay. So if you are set, you can add more. Like if your emp set also, like let's see both. Okay. If you take your emp list, it has so many methods like this. Okay. If you do emp list dot add all clear contains equals for each get hash code index of E70 iterator, it has so many different methods to use. Okay, like if you want to convert this emp list to array, if you want to convert your array list to array, you have the toArray method also. Okay, if you use this toArray method, your array list will be converted to an array. Okay, and similarly to string sort will basically sort these elements in some ascending or descending order. And likewise, if you see, there are so many methods. Okay, clear will just simply empty it. It will remove all elements. Okay, contains will basically check if it contains a certain element or not, right? If it contains a certain object or not, to verify that, we will use contains method. And similarly, if you take set also, it will contain a lot of methods like this. Okay. If you do set, it has also add all, clear, contains all equal. Same methods that are present in list are present in set also, like toArray, everything is present. Okay. So the only key difference is set will not store duplicates, whereas list will store duplicates. Okay. So your efficiency comes into play when you try to use all methods. So I'll just leave that up to you guys to practice. Okay. So this is all with respect to list and set. Okay. Any questions here? Any questions here, guys? Any questions here? Now, if you see, this is a map. Okay, I'm creating a map, which is basically nothing but this key value pair thing. Okay, you see here, and I'm storing a key. I want my key to be string value, and my value is nothing but employee. I want to store employee objects like how I am storing in a list, right? Even E2, E3. Similarly, I want to store employee objects in my map. So I took hash map. Okay. So the key, this is a random string I can give any, I just want to give a string value. I'm just giving unique string value. So here my values are even E2. I'm just storing two values. So if you see here, hash map, array list or set, if you see they have add method, which will take the object it want to add. But when you see the map, it has put method, and put method is taking two values. Okay, first one is key and second one is the value. Two arguments your put method is taking basically, right? And if at all you can print the size of this hash map, right? Like this. And if you want to iterate to hash map, then your iterator doesn't work. Okay, you have something called entry map. I'll just show you that code. You can refer to this Geeks for Geeks. It's a very good site to understand concepts and all. Okay. So now, yeah, if you see here, they created a map here, right? Map string comma string. So the key is string, value is also string. So you have certain things like this, right? And then if you see here, this is what it is. They're using this entry set, the for each loop style they're using here. So I'll also use same. For each loop style. But in our case, it's an employee, right? Not a age map entry set. Yeah, that's all. Now, if you see this for loop here, right? We are basically on this map, we are calling an entry set, and this entry set will give one entry like this. Entry set will return one entry. This one entry will be returned by your entry set. This one entry, when you call entry set, this one entry is received, and this one entry comprises of key and value, right? So this map dot entry is entry. When I say entry dot get key and entry dot get value, you get the key and value. So now let me just. Now if you see, the map contains two elements, right? E1 and E2, employee 1 and employee 2. And when I'm trying to print it, you can see the values. This is the output. Okay. Any queries here? Like your hash map by default, it doesn't maintain the insertion order. If you see, first we inserted employee 1, next we inserted employee 2. But the output, if you see, first employee 2 got printed. If you want the insertion order, which hash map you should use? If you want employee 1 to be first and employee to be last, every time you try to look into the hash map, which hash map you should use? You will use
hash
linked hash map.
Link.
If you want insertion order, hash map doesn't maintain any order. If you insert 10 elements, you won't know in which order, what inserted first, what inserted last, you won't know in a hash map. But if you use linked hash map here instead of hash map, then it will maintain insertion order. Just see, look at the output here, guys. I inserted employee 1 and employee 2. Look here, employee 2 got printed and then employee 1. Okay, if I just try to execute this again, then it's same. But I want my employee 1 to appear first, right? So I can use a linked hash map here. Linked hash map I can use. Okay. when I use this, now look at the output. Your employee one will be top always. It maintains the insertion order. Okay. Understood, right? Any queries here? Any queries here?
So this entry we just use for the hash, just
Hash
for
map.
the
Only for
hash map.
iterating map we use entry set, because here we have two values, key, two attributes, key and a value, right? Unlike list and set, you have only one value there, which is the actual value. Here for every value we are computing key also. We need to put the key as well, which should be unique. Okay.
Okay.
So entry set we will only use for map, because map is a different data structure which stores key and a value, two values. So in map, right, retrievals are quite fast, because if you know the key, suppose if I know the key, like I want to get an employee to object, for example, what is the key for this? What is the key for employee to object in my map? The example you are seeing. What is the key, guys? What is the key? Come on, guys, speak out. What is the key for my employee to object? What is the key for employee to object, guys? I want to retrieve this. Okay, I'll just show the output here. I want to retrieve Asha value. What is the key? I want to retrieve value Asha from my hash map. Okay, which key should I use? I'll use this key, right? Employee -2. Yes or no? Guys, are you following me?
Yes, sorry, I was talking on mute.
Okay, yeah. Simple question. Okay, so if you know the key, right? If you know the key, you can use the hashmap.get method, and inside the get you put the key, and since it's a string value, I need to enclose it in double quotes. If you put the key like this, right? So you will get the value straight away. So that means if you know key, accessing certain values are quite fast. If you see here, right? I used get employee to, so I got the value Asha here, right? So the get method you have here. So put method is to put elements into hash map. Get method is used to retrieve the values from the hash map using the keys. Okay, get and put. Put method, get method. Okay, so you have hash map offers you these kind of things. Okay, yeah. Okay, so that's what it is with respect to hash map. Okay, if you see here in this example, if you see this part which I'm highlighting here, I'll just probably take this to end. Look at the line number 76, this line. What you understood by this line? Tell me. It's looking like a complicated syntax. Okay, but what do you understood? What are we storing in a hash map there?
Key and value.
What is the key?
Employee ID.
It's not employee ID, right? What is the key? Look at that line and say, don't assume anything. End of the day, your hash map contains one key and one value, right? if you look at hash map or which is basically your hash table, there are two values always. One is key and one value. This key can be anything. It can be integer, it can be character, it can be string, or it can be an object itself also. And similarly, your value can be anything. It can be integer, it can be char, uh, it can be a custom object, or it can be anything, right? It can be anything. Now tell me what is this?
It's a string.
Here the key is a string, and what is the value?
Value is list.
Value is list object. Value is not a single employee object. Value is list object. That means your list contains multiple employees. See how advancedly we can use hash map like this. So if you see in my hash map, if you see here, I'm saying EMP1, EMP2, two lists I am creating. Okay, two values. And if you see EMP list is this empty list I declared. Empty list is the first one which we created, this particular list which we created earlier. So I'm inserting list as a value here. Okay, so this is how you can leverage the collections to store more complex object types. I think you can, as a value can be anything, right? So whatever you put here, that is the type of value. So this is like more advanced uses of hash map. Now if you see here, I took this, now if you look at this particular syntax now, right? What this will do, tell me, can someone tell me what this is going to do?
Get the.
What will be the output of this particular line?
It will get the name, first employee name, and convert it to uppercase.
So what is the value here? What will be the output? You guys already know, right?
Yes.
What will be? I'll show the previous output. Employee 1 contains value Varsha, employee 2 contains Asha, right? So what will be the output here?
Employee 1, Varsha in capital.
Varsha in capital letters, right? So okay. If you see here, you first you did map.get, okay, which will print the value Varsha, and sorry, employee 1 is nothing but it will store employee 1 object, and on that object you called get name, get e name. So what is the employee 1 name? If you see here, this is the, you created setters here, right? This is setters and getters. Using this get e name method, we are returning the e name here, right? So this get e name, if you see, look at the employee object class which we created, you are using this setter method. Here, this will be replaced by e1, okay? And you are saying e1 dot get name, which will return the string value, which is Varsha, and then to uppercase will just convert it to the uppercase like this. Okay, so this is what it is. So yeah, any questions guys here? I think that's all. Whatever I want to tell you as part of collections, I have done. And there is one more thing, okay, which is using comparator and comparable interfaces. Okay, so these two are helpful if you want to sort comparable. UMPRABLE, comparable and comparator. Okay. Comparable and comparator. Okay. So you have these two interfaces, okay, which are quite popular if you want to sort these elements. Okay. We will use these interfaces, comparable and comparator. I gave you one program in my Java assignments, whatever I shared you, I gave you one program, right? You like this one. Write a Java program to sort array list of custom objects by property. Use both comparable and comparator. Okay, this is one assignment. So this is also one use case that you kind of use quite a lot. Okay, and And if you see here, on top of this, right, you have array list and all. You have another thing called collections class. Now, don't get confused, okay? Collections class. There are two things here, okay? One is a collection and another is a, I'll open this. You see, this is a class, collections, yes. And you have just collection. You have another just collection also, okay? Let me just open this. Let us just open this. Now, if you see, you have two things here. One is the collection and collections class, okay? You know collection, right? Collection is this is this one, this the interface, the hierarchy one. Whereas collections, it's a class, it's not an interface. Look here, this is an interface which extends iterable. This is what this is the contract that defines how what all methods or collections should contain, like array list and all. And then you have collections. This is a class, this is a different thing. Both are not same, okay? And this will contain so many utility methods which will help us to do things more efficiently, okay? When I say efficiently, it has so many methods, like it would provide sort method, for example. I'll just show you some examples, okay? Collections dot, when I click on collections dot, like you see, you get so many methods which you can use to like you have max method. Max method will bring the maximum value in a particular array list. Suppose if your array list is storing these values, right? 1542. When you call max method, it will just give you the maximum value, which is 5, right? So you have those kind of so many much more utility methods, more powerful methods you have to leverage more functionalities. And one important thing, it has this functionality, synchronized map. So what is this synchronized map? Okay. If you see, by default, none of your collections are thread safe. Okay. That means when you have multiple threads accessing your collections, then data may be inconsistent. Okay. None of your collections, all these collections, this linked hash set, array list, linked list, priority queue, tree map, hash map, linked hash map, none of these tree set, none of these are thread safe. Okay. In a multi-threaded environment, your data will become inconsistent. So if you want a thread safe version of these collections, you can utilize this collections.synchronized map and 𝐴𝑔 map. When you say this, your map will become a thread safe one automatically. Okay, this will return a thread safe map. Okay, so multi-thread, it will give a map. So when you use this synchronized map, then your threads will create a lock on this map. If you just use a normal map, your threads won't lock the map when it is trying to read or write some data into map. Your map will not be locked. But when you use synchronized map, your threads will lock the map. That's the key difference. The synchronized maps are efficient for your multi-threading environment. So likewise, your collections has a lot of things. And yeah, this comparable and comparator is one thing. Like what is comparable and comparator, to understand more is like the idea is to sort the elements in a particular collection. We use these both comparable and comparator. Okay, so to just give you some overview, I have an employee class here, right? So I have already overridden toString method. Okay, if I want to store this in hash map, for example, right? What is the key attribute of hash map? It should calculate hash code for every value that we store. Yes or no?
Yes.
Are you guys are understanding me, right? For a
Yeah.
primitive data types, like if you are storing integers or characters or strings in hash map, your hash map is intelligent enough to calculate hash code itself. But when you store custom objects like this, your hash map will not be able to calculate hash code for itself. Okay, like as a programmer, you have to tell how it should calculate hash code when you store these values in hash map. Okay, to do that, what you just simply do, you will override the hash code method. That's all, nothing much. Okay, if you know, if you like the hash key, and it returns an integer always. Okay, it returns an integer. So I know my employee ID is unique for everyone. Okay, so for example, I'll use this for this assume, but in real scenario, I might be returning an employee ID. Okay, like this. Okay. Hash code. Okay, this is the hash code. You guys know, right? It's part of the object class hash code method. 𝐿𝐵𝐽𝐸𝐶 object c dot object. Now, if you see c dot in object class, you have this. In object class, you will find the hash code method here. Okay, hash code method. Okay, it's not coming here when I click dot. That's some problem. Let me just remove this. No problem. I'll just do that here. C dot. If you see, my object contains the hash code method. Okay, so your custom objects, since for primitive types, your hash code will automatically calculate hash code. Okay, but for custom objects, whatever we create like this, your hash code is not calculated automatically. Okay, your hash code is not calculated automatically. So so we can make use of the your custom objects should override hash code method of object class, and it should return some unique integer value. Here I'm trying to return employee ID as, and here my employee ID is string, but I can convert this to integer and I can return this as an a hash code. Okay, because my employee ID is unique for all the employees in certain organization, right? Like none of the two employees will have same employee ID, so it will be always unique. So I can return employee ID here, or else I can compute some unique value. I can write some logic to compute some unique value also. Okay, so likewise, the hash code is one thing. Like when you want to store custom objects in hash map or linked hash map or tree map, any of these sort, right? You should definitely override hash code. Okay, else it will not be able to store objects efficiently if you're not overriding hash code, because these are the custom objects. Okay, that is one thing. And if you want, suppose you're storing employee objects in an array list and you want them to store in a particular order always, right? So you can always use the comparable interfaces. When you do this, okay, so when you do this, you need to override this compare method, and you should define the logic here, whether you want to sort. Comparable will only help you to sort your employee by one property. So what all properties you have in employee class here? You have employee name, employee ID, experience, salary, age. So if you using comparable, you can select one property. So that means suppose you are taking employee name, and if you implement comparable, and when you are storing these employee objects in a list, your employee objects are always sorted by employee name by default. So your comparable helps you to pick one property and always sort your elements based on that property. But if you use, I told you about other one also, right? The comparator, right? I told you about the comparator also, this one. Okay. I told you about the other one, comparator, right? If you take this one, then you can sort using employee name, employee experience, salary, age. You can use all the properties. Okay, that's the one key difference between comparable and comparator. With comparable, you can pick only one attribute, one property of a particular class. Whereas with comparator, you can use comparator to sort all, using any of these properties, you can sort the employee objects in a particular collection. Okay. So this, you can Google it, you will find a lot of examples, and that's why I gave you this as an assignment. Okay. Now I'm sharing the assignment in the chart again. Just take this. I think with this we finished our Java course, guys. Okay. We have Java 8 concepts to cover, streams and lambdas, which I'll cover in our during the end of the course after finishing Spring and Angular, right? Just a 2-hour session, one to 1.5 hour session to cover Java 8 concepts. Okay, I have the slides here, but if I start telling it now, it will be difficult for you to understand also. Okay, the Java 8 concepts, functional interfaces, lambda expression, streams, and optional class. These are part of Java 8. Okay, which I'll discuss in the end. Towards the end of the course, we will discuss Java 8 features. But by that time, I want you guys to finish this Java assignment. You have 10 programs here. Implement all the 10 programs. You will find Google solution for each and every program here. Okay. Like first two programs talks about how you can work with dates in Java. Next program talks about a string. And the next few programs, they talk about how efficiently you can use collections, and you have a file stream API in Java, which is really important API, and where you can, how can you read, suppose this is a text file, right? How can I want to write a Java program which will read this text document. How can I do that? You have a file stream. So for that also, I gave you one program. So these programs will cover pretty much all the concepts, and the previous assignments, that if you're thorough with these, right, I think you can consider yourself as an intermediate Java programmer, definitely not a beginner, right? And then you have the 10th question, which is basically designing a parking lot. If you try to, I think first spend a month probably, try to design it on your own, right? If at all after a month, then try to look at the solution here. I gave you the solution link also, code. Okay, so this 10th question is basically tests your overall Java knowledge. And if you attend manga companies, right, like Facebook, Meta, or Amazon, Google, Netflix, and all, right, there they will ask you these kind of questions. They'll just simply ask you, can you write a Java program for me? And in the Java program, design a parking lot for me. What is a parking lot? You enter a parking area, you take a parking ticket. It will tell you, it will give you some number where you can park your car, right? So the system, whatever is giving you these tickets, it should know how many slots are filled, how many slots are open, and all. It should know that, right? It should be able to manage this parking properly, isn't it? So you need to design a such kind of a software, for example, right? Parking lot using Java. So based on all the concepts we discussed from day one, object-oriented concepts, the data types, variables, loops, control statements, classes, interfaces, and now the collections, right? And the exception handling and the multi-threading. You combine all these concepts together to develop this particular solution. So if you do this, you will definitely become the expert Java programmer. Okay. So, I mean, if you, I expect you to solve 20% of it, not definitely fully, but if you take some approaches, then it's, it's pretty easy, right? So it's like creating a parking lot with 6 slots, allocated slot number 1 for first car. This is your car number, and it is allocating slot 4 for this. And if other cars are coming, it is simply saying parking lot is full, some messages like this, right? So how it is implemented? First, vehicle class, your vehicle, right? Your vehicle number and color, your vehicle number, registration number, parking slot, ID number, ASMT, park vehicle, blah, blah. Some lot of classes that you need to create, and you need to take object-oriented design approaches. You need to make use of inheritance, right? If you design this, the solution, like I said, it's already available in this GitHub link. It's available here. You can download the Java code from here also directly. But at first, I want you guys to think and develop on your own. This is a solution. Okay. You have a lot of, this is the complete solution, lot of Java classes here. Okay. But before going in this to solution, I want you to guys to give it a try on your own. And then for a month, take a month time, try to do it on your own. Okay. So if you try to solve this, it will really improve your Java understanding, and you will definitely become the expert Java programmer within no time. Okay. So try to finish all these assignment, guys. For each of this assignment, you will find a solution in Google, right? And I would expect you to finish this assignment by end of our course, except the 10th question. Okay. So 10th question, except so 10th question in this article, you have detailed explanation also. Okay, so you can go through it and you can do it at your own leisure time. But these 9 questions, I expect you to finish by end of our course. I think our course will be finished in next 2 weeks. Okay, so in the next 2 weeks, you should try to finish all these 9 questions, and in the meantime, you come back to me with any solutions. If you don't understand certain program how to implement, you can just reach out to me. Okay. I'm just sharing this assignment. I hope everyone take it from the chart. Okay. So we'll drop here for today. Any questions, guys? Or are we good? Varsha, any questions?